Morning,
Good
everybody.
morning, sir.
Good morning. What about others?
Good morning, sir.
Good
Good
morning, sir.
morning. Yeah. Good morning, everyone. Back here with a lesson on IoT class. In our last class, we are discussing on how the devices and the gateways will play in a very much important role in M2M and an IoT projects. Further, now we have seen like that how a device actually will act like a gateway and how a separate gateways and what about the basic devices and advanced devices when we are going to use and all. We continuing with that. We'll start with our PPT. Yes. Now the next topic will be on local and a wide area networking. In a local and a wide area networking, first what actually our device. First, we should think about devices, some particular problem, and that particular device, which sensors I should use and which actuators I should use to solve my particular problem, and how I can reach my objective or a goal of a project, and how my device should be, and what code actually I should do to gather the information from the sensor, and how I should do the filtering of that particular data, and how I should aggregate that type of data. And after aggregating everything and all, whatever useful data is there, that data I should transfer to a other backend server. A backend server here maybe of your cloud and whatever dedicated server will be there like that. To transfer from your device to that particular backend servers, you need a network. So that network plays in a very much important role in a second category. So you should know about an network also when you are doing an IoT project, which type of network I should utilize for my particular project, and why this particular network I should choose. Why? Because the connectivity plays in a very much important role. Whatever maybe your sensors, sophisticated sensors you are using, actuators you are using, and your board is very good, and you did a very excellent code. It's working, everything is there. But the main objective is like that the data should be transferred to the backend servers. From there, it should be circulated to the other end of the users, those maybe smartphones, whatever maybe other end persons will be there, those who are operating remotely our device. For this network, the connectivity of a network will also plays a very much important role. So this particular session will tell us, according to our IoT project, what are the how the networks we should choose, and actually the first thing is what is why we need a network that we are going to discuss, and later on two types of networks will be there, LAN and WAN. So when we should use a capillary like LAN network, and when we should use a wide area network. Especially in the projects that we are going to see in this particular session. The ability to exchange pieces of information using telecommunication technologies has changed the world and will continue to do so for the foreseeable future, with applications emerging in nearly all contexts of contemporary and future living. Typically, devices are known as nodes of the network, and they communicate over links. This actually in the last session, computer networks and all, you have discussed actually what is a communication and all, especially in our terms and in our IoT terms and M2M terms. If you discuss, the telecommunication technologies plays in a very much important role because of that telecommunication technologies only today the IoT has been in existence. Internet of Things is existing, I can say like that. So without the telecommunication technology, there shouldn't be the IoT projects today. Why? Because you can see how the internet today is there from last 5 6 years. If you observe back, if you go and especially in 2003, 2004, 5 and all, not too back, 2003, 2004, 5. When you see the way the mobiles which we are going to use and what purpose the mobiles we are going to use, and today for what purpose we are going to use mobiles. There in the beginning, the mobiles is meant only for voice calls. In beginning, they have thought like that. This is the one communication which can be used instead of your landline phones. This will be a good one, and you can do any voice calls when it is a term of almost all to say 1G, 2G at that particular time. When it's came to the 3G, almost all when it comes to the 3G, the concept of internet has been introduced. Means a smartphone concept. Sorry, yeah, just a minute. Just a smartphone concept has been used in that particular 3G technology. Later on, the generation has shifted towards using an internet, especially chatting and sending messages, like that concepts it came. And when we full fledged we came into the 3.5G, we started with an apps like means Facebook and WhatsApp. So all this particular things. And presently in a 4G era, 4.5G era, which you can see rather than calling the voice calls, we are using our smartphones rather than more for our internet purpose. If you compare, if you see today, it's like means just voice calls is one factor, and another 90% of the usage of the smartphones we are using for the other purposes, online purchasing, it may be, and it may be a WhatsApp, it may be a Facebook, LinkedIn, and Twitters, whatever may be the thing. So we are using, and how much internet we are utilizing. So this is a one important thing which you should know. In our network terms, always whenever we will think, means whenever a connectivity will be things, the devices will be called as nodes. And nodes, the link between that particular nodes or communication between that particular nodes will be called as links. In modern computing, nodes range from the personal computer servers and dedicated packet switching hardware to smartphones, game consoles, television sets, and increasingly heterogeneous devices that are generally characterized by limited resources and functionalities. Now, in this modern computing, this one thing. No, nodes range from a personal computers. What are our nodes? Today in this particular time, if I tell what are our nodes, then you will tell the nodes are nothing but our personal computer servers, and where a dedicated internet should be there. That's a packet switching hardware which will, and then you need a smartphones. Means smartphones, game consoles, television sets. Increasingly, the heterogeneous devices, other heterogeneous devices also, which you can use and you can connect to the internet, and this made the resources and the functionalities more. The limitations typically include the computation, energy, memory, communication, the range, bandwidth, and reliability, etc. When it comes to the limitations, or we can say like that, what are the constraints which we can see in this particular thing? How much amount of the internet we are sending? And how that particular what range we are going to send this particular bandwidth, and how this particular bandwidth can be managed, and in reliability, means in real sense and all, how this memory we can have, energy we can maintain and all. The best example for this, I can tell like this. Yeah, the best example always is you can take any servers of Google, and you can take any servers of the WhatsApp, whatever may be the thing, YouTube and all. What will be the energy and memory it needs? How many persons will be using at that particular time? So how much bandwidth it should have to manage, solve the requests. Best example, you can go within a Google. In now, I will ask you a question like this: at this particular time in a world, how many are using a Google website? If I will ask you like this, then you will tell, sir, billions, millions of people they may be using at this particular time. We can't expect. So what will be the traffic then to that particular server? How you should manage, and how you should just a minute. Yeah. So how you should deal with that particular range, and how much memory you can keep, how many users, if I ask you in a Gmail, how many users are there presently in a world, then there also the millions together will be there. Then how all their inboxes data will be maintained, and how you can do this data, energy, everything they will get. So these are the important things which should be known. And application specificity will be there. That is example of the sensors and actuator. When we come to our IoT projects, assume that how many sensors we need. So how all this wireless sensor network should be maintained. The best example I will tell you. See, when we come to the military or defense services, assume that I want to, we will implement a project in means in a border of that particular country. If you take, consider India only, the entire border of India will put in a surveillance, and anybody crosses, for example, now whatever a fence is there, if anybody crosses that particular fence, then automatically a triggering should be there, and it should focus on that particular camera, should focus on that particular point, and means ultra X-rays should be taken, and who are passing from that particular fence and all, automatically intimation should be given to the soldiers who are there in a bunkers like that. Then seeing their body, means what they are carrying and all, if they are terrorists like that, means if they are carrying any amenities like that, means the automatical guns will be there where it will focus on that particular persons, and just one button from the bunk, it will shoot that particular persons. Assume this is a project. When I'm not telling like that, the not existent projects. Now, if you go to Israel and all, if you see, Israel is one of the best country with an IoT based or an automatic based military services, especially how they are doing the surveillances in their borders. And when if you Google it, you can get it. And how they are keeping with the sensors and how the entire border is equipped. Now coming to the large, the vast country like India and all, we have 3,500 in one side, and 3,500 kilometers of the border will be there. So how to manage that big border, means how much sensors and actuators will be needed, and how we can make a network. So this is one of the important thing where a developer should think. So how will place the sensors, how communication should be done with that sensors to the sync nodes, and from that sync nodes, how a data can be read from a readers, and from readers again it should be taken, and you should write some code to activate the automated devices, activating actuators like operating a gun or operating some other tear gases, miss some gases, something like that. For that and all, imagine in a vast way like that, these many kilometers, how many sensors we should place, how much the differences. Now presently the sensors can communicate within 40 50 meters of an range. So how we can do this? And how these particular things can be solved? So lot of things will means how my network should be there, how much dedicated network I should use for this. So what should be the bandwidth, and how much power we need, how much memory we need. If somebody take off that particular sensors, this identifies, and take off that particular nodes and how to manage that. So all these particular things will arise. As a case study, I can tomorrow I will show you how the Israel country is having an equipped IoT military services in it. A demo I will give to you. Other countries also you can take like America and all. Coming to the next. A selected physical medium determines a number of technical and economic considerations. Technically, the medium selected are more accurately the technology solution designed and implemented to communicate over the medium. First, actually, what we should decide. Yes, this is a network I need. How we are going to decide this particular network is needed? First thing is like that. What is the physical medium? And you should first decide that physical medium technical terms, what technical terms I should need for this particular physical medium or an asset. For example, I told a border, so 3200 kilometers border is there. So what, how technical equipments or devices I should equip in this particular project, and what will be the economic considerations of that? Underline this is very much important. Now, rather than taking a military service example, now we'll go to the drip irrigation. Now, in a drip irrigation, I will tell you like this: assume that a prototypes anyone can do, and anyone can show like that. And keeping a moisture level sensor beneath the soil and reading that particular moisture level. Pump will be automated, water will flow, and then sprinklers will on automatically. Prototypes, anybody can show the prototypes. But assume that a farmer is having a land of some 3 acres to the 4 acres there, and for the 3 acres to the 4 acres, a plantation will be there. Assume a grape plantation or any that type of plantations will be there. And in this 3 acres of a land, 3 acres, you have to think like this: 3 acres of a land. In this 3 acres of a land, how we can put the sensors? Where we can put the sensors? Each plant, one. If you put, assume that there is a different means distance of some 20 to 30 meters between each plant. Then how many moisture level sensors you need? Then how you are going to collect a data from that? How many nodes you need in between, means to sync nodes to collect that particular data. So how you are going to do this? What is, okay, we'll plan. Yes, sir, we can do technical terms and all. We have evaluated and we have seen these many sensors has been needed, and these are the sync nodes, and one mind reader will be there. So in entire 3 acres, we can plan like this. Okay, good enough. What will be the economic considerations? Assume that if you tell when the farmer that entire project will be there, and this entire project will be of some 5 to 6 lakhs or 10 lakhs. Finance. No, farmer cannot offer, especially in India, like developing a country, farmers cannot offer that particular things. So how you will deal with? Then how will you make a network of sensors and devices? Then how will you connect that to an internet? So these type of things, once if you are doing a project, you should think on that. Technically, the medium selected are more accurately, as we have discussed, and implemented to communicate over the medium. Is the primary enabler of a bandwidth without which certain applications are infeasible. Simultaneously, different technological solutions require different economic considerations, such as the cost of deployment and maintenance of the networking infrastructure. This is underline this. In exam also you have to write this. The technological solutions require certain economic considerations such as the cost of deployment. How you are going to deploy this for 3 acres? Showing a prototype with to one plant, putting a moisture level sensor and the temperature and humidity sensor, digital temperature and DTH sensor, and switching on the small sprinkler and small water pump which works with 12 volts or some 8 volts pump working and showing water coming out. It's not a big task. So what about in field or in practical? How will you deploy this particular type of projects? Okay, deployment anyway you can do. and how will you maintain that, and how will you give a service to the farmer, the maintenance when you want to cut the assume that cutting of the grape plants will be there or some other plantations will be there. At that particular moment you want to take off all that particular equipment, again he has to install one of the sets, means entire drip system he has to take off and he has to implement that again back. Now what about our equipments, however what about our connectivities, so how, what about our networking, so can farmer have an internet at any time in his fields, so what will be the internet charges, what type of internet we may need with lot many of sensors and all to communicate with him think. So this is a one constraints which will arise always. This is the simplest form of a network that requires a knowledge of route to communicate between nodes. Okay, whenever now you are coming back to the networks, how we are going to communicate? I will communicate from node to node. This is a physical links will be there. From that particular physical links we are going to communicate. Assume that A, B, C or three nodes are there, and then from A to B I am going to communicate B to C. There is a connectivity. When I want to communicate from A to C via B, I can communicate. So therefore, if node A wishes to transfer data to node C, it must do through node B. Thus node B must be capable of the following. What? Communicating with both the node A and the node C, and advertising to node A and the node C that it can act as an intermediary node. So this technology or a type of a network, your devices should do. Don't think that, sir, I will keep a computers. Computers can communicate, not our issues. And your smartphones, yes, it can communicate. But what about our devices, mechanical devices or any automotive devices? How these devices should be enabled to communicate, and how these devices should act like an intermediary? That should be known in our terms. Now, it is essential to uniquely identify each node in a network, and it is necessary to have cooperating nodes capable of linking nodes between which physical links do not exist. So underline this. This is another one important point. That is, each and every node or a sensor, what you are going to take, and everything should be identified in a network. So this is very much important. How will you identify each and every sensor there? Which is from which sensor, what data is coming? In 3 acres of a land, assume that there are some 180 plants, approximately I am telling. Some 180 plants are there. The 180 plants, each plant, assume that you have put up on one sensor. So 180 sensors will be there. So 180 sensors, when you take into the consideration, in that 180 sensor, which sensor is sending what, how, which moisture, means how much moisture level, then how you should act, which valve should be opened there. So which means number of valve number should also be taken into the consideration, and that valve number should also identified through the thing or a network. So how you are going to identify that? In modern computing, this equips to IP addresses and routing tables. Thanks to the standardization. So okay, in this modern things and all, we'll take IP, and IP is the one which will identify, means you know everyone already you have studied computer networks. So in a computer networks, any device should be identified. It should be identified with an IP. Okay, IP will be given. For IP will be given to our board. Means whatever the node is there, either Raspberry Pi or using Arduino, whatever may be the thing, one IP address should be generated. Through that IP address, you are going to communicate. That is the one thing. And each GPIO, means general purpose input output lines, will be there. With that particular lines, you are going to communicate. That means you have to calculate that how many these type of nodes, means boards is needed, which can be identified in a IP address. How many IP addresses is needed in this particular project? So how to manage these IP addresses? So entire thing will be identified with that particular. Any doubts is there, you can interrupt me and you can ask. So behind the basic ability to transfer data, the speed and accuracy with which data can be transferred is of critical importance to the application. This is vast, very much important. Okay, my project is working. I will show the project demo. Everything is there. Data is transforming. Right. What speed it has been transforming? What is the accuracy of that? For example, assume in a emergency projects, in any emergency projects like that. For example, I will tell you any fire automations you are doing. In a fire automations and all, so particular sensors you have kept, and that sensor will be communicating, means you are taking data and you are going to communicate that. And then somebody will tell, okay, switch on, means in a mobile they will tell on. If it takes more time to actuator to run, it left to speed. As I told you that when we are using all free things, free cloud and internet will be of our mobile internet if we are using and all, what will be the speed? You can imagine. Even for our online courses itself, we can't gain the speed and accuracy. Then in such a devices and all, accuracy plays a very much important role. Alarming the fire extinguisher, if somewhat it will be late and some disconnectivity will be there, it will make a very, very, very critical problem, especially for this type of an applications. This plays very much important role, like accident application, which Shashank is doing. In that and all, the connectivity and accuracy of sending that particular location in time sending is very much important. So irrespective of the ability to link devices without the necessary bandwidth, some applications are rendered impossible. So if it doesn't maintain very good bandwidth, even though you are linking the devices, nothing means you doesn't achieve your objective. So that you should know always. Coming to the next, consider the differences between streaming video from a surveillance camera. For example, just for an example, according to the syllabus, this is the example they have given. Now you can see streaming of video in a surveillance camera. We'll take, or somebody means Gaurish is doing this particular project, where in a surveillance camera motion identification they have to do intrusion detection system. Same example they have given here. So streaming video from a surveillance camera, for example, any intrusion detections system based on a passive sensor. Means you will place one sensor within that particular camera, somebody is going, the sensor will sense that and intimation will be given. So simplistically, streaming video requires a high bandwidth. So always watching the video and streaming that particular video always needs a high bandwidth, whereas transmitting a small amount of information about the detection of intruder is somebody is crossing the fence, somebody is somebody is crossing the border. Just intimating that information, it may need a tiny amount of a bandwidth, but surveillance needs a higher bandwidth, but a higher degree of reliability with respect to both the communication links and accuracy of the detection. So you can take in this particular examples how a bandwidth will plays a very much important role. Now we will see the need of a network where the network is heterogeneous. If you think, assume the same example as ABC, what I told, if ABC are same type of nodes, they can communicate easily. Assume A is a different category node and B is a different category node and C is a different category node and different types of networks that has been connected. Then how you are going to communicate? For our IoT projects, this is a major one, means heterogeneous networks. So coming to this particular constraints on networks, which you see, abstracting, consider that node A is a device that can only communicate over a particular wireless channel of limited range. There is a restriction. Node A will always works with only this particular channel. Example, channel number 11 in 2.4 gigahertz ISM band over less than only 200 meters, it will work. Means node A can communicate with only within a range of 200 meters with a bandwidth of 2.4 gigahertz and channel 11. Now, Node B is capable of communicating with Node A, assume it can communicate, but also with application server with service capabilities, that is Node C, with which it can connect using wired Ethernet. Assume, imagine, you have to imagine, Node A is our sensors, some board, something like that, so which can communicate only in a fixed range, only 200 meters it can communicate. As I told you that our sensors, our sync nodes, whatever will be there, it will communicate within a range. So only in this hearts only it can communicate. But the B, whatever is there, the board, whatever you kept, assume it can communicate with node C. It can communicate with node A also, and it can communicate with node C also. And B is connected with C with an Ethernet. Means assume Ethernet internet has been connected. Example, over a complex link using a standardization protocol, web service such as REST at the application over the internet. Now C is having internet. C is having internet. C is connected to internet, and B is the one which has been connected through a LAN to C, and A is the one particular other network which will be connected only 200 meters in an analog mode. Now consider that node B may be connected to a subnetwork. No, consider, observe carefully. Now consider the node B may be connected to subnetwork of child nodes similar to node A. Not only node A it can connect to the multiple nodes. Node B can connect of up to thousands of similarly constrained devices A1 to AN. Now A I changed. Not only one A, I need a plenty of sync nodes which can manage the plenty of servers, sorry, sensors. So where the entire borderline I have taken. Now my this side A will become A1 to AN. Why? Because I need a n number of sync nodes to manage a plenty of sensors there. Now, these thousands of devices may be equipped with sensors deployed specifically to monitor some physical phenomena. Now, underline this. As I told you, all A1 to AN assume that these are equipped with sensors. These are the sync nodes equipped with plenty of sensors deployed in a physical phenomena. They can only communicate with one another and node B. That node B is it can only communicate with node B. It doesn't know anything. But C is having internet. Keep in your mind. C is having internet, but it can communicate with only node B. Then node B is connected with Ethernet LAN to node C. May communicate with each other over a single or multiple hours. Consider that the owner of the wireless sensor networks wishes to obtain a data from each of the A1 to AN devices in the wireless sensor networks. Now I need information from every nodes of that. Means A1 to AN, multiple sensors will be there. I need information. However, the preferred way to read the data is through a web server or an application on a smartphone tablet via Node C. Means from Node C, it has been, Node C is having internet. No, Node C is connected to your any server or a web application or a smart phone like that. So where some intruder, somebody comes, they can see and they can watch on that particular sense. Therefore, a networking solution is required to transfer all the WSN data from nodes A1 to AN to node C. Underline this. Think in a big way. You have to think in a big way. It's not a small one. A1 to AN. N is not told. It's a variable in here. It may be in a thousands. It may be in a thousands. It may be in a lakhs together. You can consider. Now, so how you are going to communicate? Through node B. This is now a complex networking infrastructure and is representative of many potential embodiments of M2M and IoT technologies. Now, this is the one. This terms is any doubt is there here, you can ask me. So this is now a complex networking infrastructure and is representative of many potential environments. Many constraints will be there of M2M and IoT technologies. Now back here. A local area network was traditionally distinguishable from a wide area network based on geographic coverage requirements of the network. Now, this is the one important thing as IoT developers you should know. Now, two types of networks is there. Here, what are the two types of networks? Local area network and a wide area network. So, LAN was traditionally distinguishable from WAN based on your geographical coverage requirements. I want to communicate from my device to another device with a leased line. Means not a public internet. Just I want to communicate in a large way. So how you are going to do? For example, I'll tell you now. You take a border example only. You need a van there. Why? Because 3,200 kilometers it has been spread out. Your entire project, and to maintain that entire sensors and actuators, nodes, everything, you need a separate dedicated network there. Imagine a kilometers there. So for that, WAN is the one which must be used, not a LAN. So coverage requirements of the network and the need of the third party or leased communication infrastructure. So here, this is another one, the coverage requirements of a network and the need of a third party. So what type of internet I need, either a leased line I need, either a simple public internet is enough for me, which I can use with my hotspot, either a leased communication infrastructure I need. So that plays a very much important role. Now coming to the next slide. First, we'll discuss wide area networking. So, what actually the wide area networking and how the role of wide area networking will be there in a M2M projects or IoT projects. WANs are typically required to bridge the M2M devices domain to the workhall network that thus providing a proxy that allows information, data commands, etc. to traverse heterogeneous networks. I will keep a sensors there, SIM routes there in a border. From there, I need a wireless connection to internet. Means some other device where bunkers will be there, where the soldiers will sit in. Assume the distance I can say like this from a borderline, almost all it should be means the information should fed from a sensors to that is around some 10 kilometers again inside. Now imagine what type of an heterogeneous networks you may need. So how to communicate with the end sensor? This is seen as a core requirement to provide a communication services between the M2M service enablement and the physical deployments of devices in a field. Underline this. So how means what way you are deploying the physical devices, in what vast range you are displaying the physical devices. Based on that and how to connect your main device means your control room will be there. As I told in a bunker, a control room will be there apart from your deployment area 10 kilometers away it will be there, and your deployment area will be of that much 1,000 kilometers means 3,200 kilometers. How many bunkers is needed, how many sub networks you have to make, and how that sub networks will be connected with each other. So all these things when you see, so you can think about on a WAN, not a LAN, right? Then the M2M gateway service is typically an integrated microsystem with multiple communication interfaces and computational capabilities. So M2M gateway device is typically integrated a microsystem that we know. Multiple communications interface and computational capabilities. That means it should communicate with a multiple ways. When intruder are coming, so assume, for example, I will tell you, a animal will cross the boundary line. Just for a second, a bird will cross the boundary line. So crossing a man with some destroyable amenities like guns, bombs, like that, crossing an ordinary man, crossing the birds, crossing some animals. So how you will manage this? How will you differentiate this? So how a microsystems, how a multiple communication interfaces you should do this? How your surveillance cameras there, how your sensors, and how you should make this particular differentiations. It is a critical component in a functional architecture as it must be capable of handling all the necessary interfacing to the M2M service capabilities and management functions. That means whatever you are placing means that functionality architecture should solve all these particular problems. It's not so easy that I would have told you that just you keep some sensors there and you keep some cameras there and you can do. Especially when you think about this, why I told ultra X-ray cameras should be faced means when ordinary human is crossing. So if we do ultra scanning of him means X-ray of him inside what he has kept including his bones, everything you can see. But that means whether he is carrying inside, whatever in the body, what he is carrying, his coat, everything will be there inside bomb, maybe something like that, RDX, something he can have, whether how he is coming. So for this and all, this functionalities or capability means the project should have. So this is not so easy like this how your functional architecture should be there. First, you must decide. Continuing with wide area networking, the access and core network in ETSI as the standards I have told you, European telecommunication standards. So M2M functional architecture are forcing to be operated by a mobile network operator, MNO, underlying this. So we are going to use a mobile network operator. They don't think like that, your mobiles. A mobile network operator means a separate leased internet provider will be there that he will provide an internet where it can be operated or even within a mobile network operation also and can be thought of simply as a WAN for the purposes of interconnecting devices and backhaul networks means others small networks means bifurcated sub-networks. Thus, M2M applications, service capabilities, management functions, and network management functions, all these things you must know. Otherwise, you can't architect your functional architectures. The functional architectures, when you want to do, first you must know what the backhaul of networks will be there and what are the sub networks will be there. For this sub networks, what are the connecting devices? Especially here, when you are connecting to the human, something like that, they will tell you, hey, connectivity has lost. Somebody will intimate you. For example, now I am teaching you, assume that suddenly internet will go off. Why? Because other end you are the human beings, I am the human being, and you will call and you will say, sir, network cut gaya or sir, network has been disconnected. Then I will see a network has not there. Wait for some time. I will stop and I will do. Means this whatever functioning is there, I will stop that functioning. Means teaching, I will stop. But assume that both ends or devices are there which is communicating. Now either device will tell you that no internet connection. No. Then how you should manage that situations? Why? Because we can't guarantee that always my network will be sorry, always my network will be in a full fledged. No disconnectivity will be there. In a last class itself, when we are doing the lab, the mini project demo, we lost the internet. Amit waited for some time. So how these things must be adapted here? How these functional requirements will be solved when you are doing in a functional architecture? The WAN covers larger geographic regions using a wireless licensed and unlicensed spectra as well as wire-based accesses. Either you can go with an optical fiber means decide. You have to decide where you need a wireless, where you need a wide, and which network means which subnetwork to which subnetwork, what type of wire-based accesses you need, either optical fiber you need, either ordinary copper wire is enough for you, Cat6 cable. So it should be decided. WAN technologies include cellular networks. Cellular networks will also be there. DSL will also be there. WiMAX will be there. Wi-Fi is there. Satellite networking will be there. Ethernet networking will be there. Everything will be there. So you have to decide that when I should use satellite networking, when I should use Ethernet networking, in what subnetwork to subnetwork I should use which type of an network. So heterogeneously, all these type of networks will be connected to main server, means main hub. So imagine here no human interactions will be there. That is the point always whenever you are doing an IoT project. So everyone should keep in your mind these important things. In M2M context, important functions of WAN include what are the important functions? We'll see. The main function of WAN is to establish connectivity between capillary networks. This is important. Subnetworks. I'll keep on telling you subnetworks. Subnetworks. Capillary networks means a small networks. That network is connected to this 3,200 kilometers of a border is there. So in what regiment? For example, I will tell you, assume along this all sorry, some 500 to 600 bunkers are there. In 500 to 600 bunkers, how you are going to partition that? So how will you give a area to each bunker? So how much network you need? So within that, either you have to make a subnetwork. So that is a capillary networks, hosting sensors, where to host the sensors, and how actuators you have to place, where actually actuators should be placed according to the region. Either all things should be known to the main server. For example, assume in Delhi, defense minister is sitting, and some means I will tell you, the chief of the military has been sitting there, and he should also know what is happening in a border. Now, if you think in this particular terms and all, so how this connectivity should be there? And M2M service enablement, default connectivity mode is packet based using a IP family of technologies. Anyway, internet means IP. So always it will be a packet based one. This family of technologies only we should use. Why? Because each starting from a sensor to starting from your main means the end device, whatever is there, or a backend device, whatever is there, all devices should know about your IP. Means packet based switching or a networking. Otherwise, you can't do. Next, the use of functionalities I'm telling. Use of identity management techniques, that is primarily of M2M devices in a cellular and non-cellular domains to grant right of use of the WAN resources. So, which person should use which devices? Which person can access which particular actuator? Which bunker person can see what? And main thing, the main person can see what? So granting right of use. So this is important again. So how in your entire wide area network you are going to do this particular things. So these are the important things which you should know. The following techniques are used for these purposes. The techniques we'll discuss in a next class. So in tomorrow's class, I'll try my level best to tell you a real-time implementations of the local area networking. Wide area I will check, especially why, because wide area I'm telling you must know the differences. Whatever projects you are doing, all are land based. So wide area networking projects are wireless sensors which will be placed in kilometers together. I'll search, especially Israel one I have taken 100% it is there. So I will check it out and I'll show you in tomorrow's class. So I'll stop sharing now. Right? Any doubts is there? You can ask me. Any doubts? Any doubts? Any doubts?
No, sir.
Right. So I'll take attendance now. Aditya, Ajay,
Yes, sir.
Amit,
Yes, sir.
Antima,
Present, sir.
Apurva,
Present, sir.
Ashwini,
Yes, sir.
Bindu,
Yes, sir.
Divyesh, Gaurish,
Yes, sir.
Gautami,
Present, sir.
Gunashekar,
Present, sir.
Harini,
Present, sir.
just a minute. Surya,
Present, sir.
Naina,
Present, sir.
Nazma,
Present, sir.
Nidhi,
Present, sir.
Pradeep,
Sir.
Preeti,
Present, sir.
Rajesh, Sahadev,
Present, sir.
Saket, Santosh, Seema,
Yes, sir.
Sinchana,
Present, sir.
Spurti,
Present, sir.
Shashank,
Present, sir.
Varsha,
Present, sir.
Yashashwini,
Present, sir.
Amrita, Ilva, ಇಲ್ಲ. Anusha,
Present, sir.
Apurva K,
Present, sir.
Sai,
Yes, sir.
Chetana,
Present, sir.
Kavya,
Present, sir.
ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಯಾಕೆ ಬಂದಿಲ್ಲ ಕಾವ್ಯ? ಕೇಳಿಸ್ತಾ?
ಬಂದಿದ್ದೆ ಸರ್.
ಬಂದಿದೀಯಾ? ಅಯ್ಯೋ ಮತ್ತೆ ನಾನು ಆಬ್ಸೆಂಟ್ ಹಾಕಿದ್ದೀನಿ ನಿನಗೆ. ಹೇಳ್ಬೇಕಲ್ವಾ ನೀನ್ ಅಟೆಂಡೆನ್ಸು? ಏನಮ್ಮ ನೆನ್ನೆ ಹೇಳಿಲ್ಲ? ಮಧುಶ್ರೀ,
ಪ್ರೆಸೆಂಟ್ ಸರ್.
ಮನೀಶ್,
Present, sir.
ಸರ್ಫರಾಜ್,
Present, sir.
ಮುರುಗೇಶ,
Present, sir.
ಮಣಿ,
Present, sir.
ಪರೇಶ್,
Present, sir.
ಪೂಜಾ,
ಪ್ರೆಸೆಂಟ್ ಸರ್.
ಪ್ರಶಾಂತ್,
Present, sir.
ಪ್ರತಿಭಾ, ಪ್ರತೀಕ್, ಸಾಧನಾ,
ಪ್ರೆಸೆಂಟ್ ಸರ್.
ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಆಬ್ಸೆಂಟ್ ಸಾಧನಾ.
ಇಲ್ಲ ಸರ್, ಬಂದಿದ್ದೆ ಅನ್ಸುತ್ತೆ.
ಹೇಳಿಲ್ಲ ನೀನು ಅಟೆಂಡೆನ್ಸು?
ಅದ್ ಲಾಸ್ಟ್ಗೆ ನೆಟ್ವರ್ಕ್ ಹೋಯ್ತು ಸರ್.
ಹೇಳ್ಬೇಕಮ್ಮ. ನೋಡ್ ನಾನು ಏನ್ ಮಾಡ್ತೀನಿ ಗೊತ್ತಾ, ಇದಾದ್ಮೇಲೆ ಬಿಮ್ಸ್ಗೆ ಎಂಟ್ರಿ ಮಾಡ್ಬಿಡ್ತೀನಿ. ಬಿಮ್ಸ್ಗೆ ಒಂದ್ಸಲಿ ಎಂಟ್ರಿ ಮಾಡ್ಬಿಟ್ರೆ ಮತ್ತೆ ನಾನೇ ಎಡಿಟ್ ಮಾಡಕ್ ಆಗಲ್ಲ. ಸೊ ಯು ಮಸ್ಟ್ ಬಿ ಕೇರ್ಫುಲ್ ದೇರ್. ಶಶಾಂಕ್,
Present, sir.
ನಿನ್ನೆ ಏನೋ ಮಾಡ್ತಿದ್ದೆ, ನಿದ್ದೆ ಮಾಡ್ತಿದ್ದ?
ಇಲ್ಲ ಸರ್, ನಾನು ಆಚೆ ಹೋಗಿದ್ದೆ.
ಮತ್ತೆ ಶ್ರದ್ಧಾ,
ಪ್ರೆಸೆಂಟ್ ಸರ್.
ಶ್ರೀಧರ್,
Present, sir.
ತನೋಜ್,
Present, sir.
ತೇಜಸ್ವಿನಿ,
Present, sir.
ಅಣಿ.
Present, sir.
ನೆನ್ನೆ ಕ್ಲಾಸ್ ಬಂದಿಲ್ಲ ಯಾಕೆ ಅಮ್ಮಿ?
Sir, no powers are here.
Okay, ma. Ashish? Ashish? Vidya?
Present, sir.
Vishal?
Present, sir.
Okay. I'll stop the recording 1 minute. Stop recording. Right.